astronomers for the first time have detected repeating short bursts of radio waves from an enigmatic source that is likely located well beyond the edge of our Milky Way galaxy. The findings indicate that these fast radio bursts come from an extremely powerful object which occasionally produces multiple bursts in under a minute. Prior to this discovery, reported in Nature, all previously detected fast radio bursts, FRBs, have appeared to be one-off events. Because of that, most theories about the origin of these mysterious pulses have involved cataclysmic incidents that destroy their source, a star exploding in a supernova, for example, or a neutron star collapsing into a black hole. The new finding, however, shows that at least some FRBs have other origins. FRBs, which last just a few thousandths of a second, have puzzled scientists since they were first reported nearly a decade ago. Despite extensive follow-up efforts, astronomers until now have searched in vain for repeat bursts. That changed last November 5, when McGill University PhD student Paul Scholz was sifting through results from observations performed with the Arecibo radio telescope in Puerto Rico, the world's largest radio telescope. The new data, gathered in May and June and run through a supercomputer at the McGill High Performance Computing Center, showed several bursts with properties consistent with those of an FRB detected in 2012. The repeat signals were surprising, and very exciting, Scholz says. I knew immediately that the discovery would be extremely important in the study of FRBs. As his office mates gathered around his computer screen, Scholz pored over the remaining output from specialized software used to search for pulsars and radio bursts. He found that there were a total of 10 new bursts. The finding suggests that these bursts must have come from a very exotic object, such as a rotating neutron star having unprecedented power that enables the emission of extremely bright pulses, the researchers say. It is also possible that the finding represents the first discovery of a subclass of the cosmic fast radio burst population. Intriguingly, the most likely implication of the new Arecibo finding, that the repeating FRB originates from a very young extragalactic neutron star, is at odds with the results of a study published last week in Nature by another research team. That paper suggested FRBs are related to cataclysmic events, such as short gamma-ray bursts, which cannot generate repeat events. However, the apparent conflict between the studies could be resolved, if it turns out that there are at least two kinds of FRB sources, notes McGill physics professor Victoria Caspi, a senior member of the international team that conducted the Arecibo study. In future research, the team hopes to identify the galaxy where the radio bursts originated. To do so, they will need to detect bursts using radio telescopes with far more resolving power than Arecibo, a National Science Foundation-sponsored facility with a dish that spans 305 meters and covers about 20 acres. Using a technique called interferometry, performed with radio telescope arrays spread over large geographical distances, the astronomers may be able to achieve the needed resolution,